All right. Good evening, everybody. Welcome back. Today we are going to talk about experimental design, true experiments. So in research, when we refer to a study as an experiment, we mean one that we are going to talk about today. If there is manipulation, there is control group, certain conditions are met, then it's experimental. When it's experimental, it's called true experimental or just experimental. When it's not experimental, we just call it a research study, scientific study. It's don't confuse this with an experiment you conduct in physics. This is different. So overall, we have 3 chapters designated to experimental designs. Chapter 7 and 8, we are going to cover them today. My plan is to talk about the fundamentals of it. Will still require you to go and read the book and study if you want to extract the full benefits out of this course. So chapter 7 will discuss experimental strategy or experimental design. Chapter 8, we are going to divide this experimental design into 2 parts, between and within. In fact, these 2 are generic. You can use them in experimental between subject designs or non-experimental or quasi-experimental between subject designs. In chapter 9, we're going to talk about within subject designs. Chapter 10 and 11 is going to be non-experimental, quasi-experimental. We'll talk about the differences between them. And the last chapter we're going to cover is going to be correlational design. Chapter 13, which we are not going to cover, is descriptive thesis. And the most crucial one is chapter 7, 8, and 9, right here. Once you understand these 3 chapters, you can pretty much majority of medical study, way more than half medical studies are in here. Once you understand correlational design, then you understand most of the education studies in education. So let's talk about experimental research. The word experimental is crucial here. Goal of experimental research strategy is to establish cause and effect relationship, causality. When you want to establish A, causes B, what it means is B takes place as a function of A. When A goes up, B changes. When A changes, B changes. It could be directional, same direction or opposite direction, doesn't matter. But certainly there is causality. It's the, even though the word relation is being used, it's causality, cause and effect. So experiment or true experiment, it must demonstrate that changes in one variable are directly responsible for causing changes in the second. Just because 2 things are related, one goes up, the other one also goes up, does not mean causality. Example, you can, for instance, if you look at the statement, smoking causes cancer. Look at this. This is causality. Scientifically speaking, one can argue that you can never you can never conduct a true experiment to support this idea. I mean, I think it's fair to say we all believe that the statement is accurate, but literally creating a study where you divide people into two groups, you force one group to smoke, and you prevent the other group not to smoke, and you randomly assign these individuals. Then you check how many of people from each group get cancer. That's how you would do a true experiment. But that's not possible. For ethical reasons, you cannot force someone. What do you do alternatively? You recruit a group of people who are already smoking. They come to you with precondition. And then you check how many of them get cancer. You check. So there is no this is not a true experiment. And decades ago, this was a very hot topic between father of modern statistics, Ronald Fisher, and American scientist, British scientist. And so he believed, as a smoker, heavy smoker, he believed that you can never establish statement that from true perspective. So two examples. One of them is goal setting increases academic performance. An article posted on the course website under this week. And another example is from the textbook, experimental study of the differential effects of playing versus watching violent video games, children's aggressive behavior. The reason why I put the article's title, because it's not in the textbook. The textbook simplifies it for pedagogical purposes. It just says relationship between playing violent video games and aggressive behavior. Well, first of all, I think I would disagree with the way it's laid out. It's not relational, it's a more causality. The title corrects that error clearly. So that's a 2018, 2008 study. I put a link here because if you Google the title, you will see abstract of the study. And this is the study. You can see the abstract. Accessing the article itself, it's going to cost you money, but we don't need it. I just wanted to show you. We'll come back here and touch upon it. The first example is by Shank, conducted in 1985 in Houston, actually. And one of my professors, they did it together, actually. One of my doctoral degree advisor. They did some together in 1978 and 1985, different studies, when he was at UFH. And in this one, which we'll come back to it again, goal setting increases academic performance. You see, there is causality. This is causing an increase in academic performance. Versus goal setting is related to or correlated with, or there is a positive correlation between goal settings. True, but weak. When you say goal setting increases academic performance, we'll look into this article a little further as we go. So there are four basic elements of an experiment. Number one, and the most important, is manipulation. So the researcher must be manipulating a variable. Manipulation means you have a variable, you decide which participant will be where. That is manipulation. If they come to you with that condition, you're just assigning them. There is no manipulation. So researcher manipulates one variable, list, and for our purposes, we'll say one variable, by changing its value to create a set of two or more traits. In our example above, right here, goal setting increases academic performance. So here we have two variables. Variable one is goal setting, participation in goal setting, to be more precise. Participation in goal setting. And this study if I were to summarize this, the researcher gets some sixth graders. I'll show you where it is on our portal. So if we go to modules under week 4, right here, article, participation in goal setting, the article here. So if we look at the research question, this study, right, this is the research question. This study tested the idea that participation in goal setting enhances achievement behaviors. Enhances. So these words, like affects A, affects B. A increases or decreases B, or A improves B. These are all experimental design verbs. Effects of this on this. So these require experimental design. So if your title is effects of such and such, that, and when you open the article, when you read the article, it's a correlational design. You know, it's a huge problem, and unfortunately, this is pretty common, way too common. So these are the words that we don't want to use are like words like impact. It's not that, you know, I wouldn't prefer those kind of fancy words. In research, we want to stick to more accuracy, and effects, improves, increases, these kind of that kind of language preferred. Influence is another word. Influence of A over B on B. These require the experimental design. So here, study tested that when you read this, automatically you understand it has to be. So in this design, we have variable 1 is participation in goal setting, and the other variables, look at this, achievement behaviors. Now we don't have one now, we have a few. Achievement variables, researcher just summarizes it. They are later on, we will see, if we scroll down, we will see that it's self-efficacy, mathematical skills, and then it's training. It's training. So goal setting, self-efficacy, that's variable 1. Variable 2 is math skills, in this case, abstraction skills, to be precise. Third is training, whatever that is, let's define it out. Okay, so these are the variables. So when we say manipulation, researcher will take this variable, participation in goal setting, will create levels. In other words, we'll create groups. You can create minimum 2 groups, obviously, 2 or 3 or more groups. And it's going to make a huge difference. I want you to think about it. If you create 2 groups, it will be like, you know, 2 groups. All I need is students who have a goal set goal, no goal. If this is the case, then you're going to have two groups. In each group, you're going to have whatever number of students you have, 10, 15, 30, even better. If you have two groups, that's what you're. If you have three groups, like this, here and in this study, there are three. They are teacher assigned goals. Students set the goals with help of a teacher. There are self-set goals, and then no goals. That is how you create manipulation. So this variable, we will call this our independent variable, the variable that we are manipulating, or independent variable, independent variable. The researcher manipulates that variable, and that's what makes it experimental design. One of the four major elements, manipulation. Now, with smoking, it's not like that. You can't assign people to group who smoke versus who people who don't smoke. Come to you with that condition already. So it's not a true experimental design. It's how do you decide whether you have two groups or three groups or four groups? Theoretical framework. If you have two groups, you will have, let's say, in the study there are 30 people. There, take a look. It's a very classic, good study. That's why I posted it. I highly recommend you read it. There were 36 graders, students with learning disabilities, middle school kids, and disabled with learning disability in math. Okay, and the IQ score was 85 to 110. Even though it's not a part of our variables, the researcher is reporting this, so why that matters. So if you set two goals, you're gonna have 15 in each group. If you have three, you're gonna have 10 students in each, and you will randomly assign it. That is manipulation. Manipulation is creating levels or groups that you assign your students or participants randomly. And it's the most important. Measurement, the second variable is measured for group. So now that we have these people, here we have a student 1, we have student 16. We're going to be measuring their self-efficacy score. If our study was a simple one, let's assume it's a simple one first, just self-efficacy. Let's assume for a second the study is that participation in goal setting increases student self-efficacy. I will measure their self-efficacy. So over here, I'm going to have a number for self-efficacy. That is the measurement. That is my dependent variable. It's dependent because its value depends on which group they are in. The independent group, I can assign them to any group. So that is the second aspect of experimental design. Third, comparison. So now that we have students, do I compare one by one? No. I will have 15 students here, 15 students over here, and I'm gonna take one number that represent each group. Okay. And same if I have three of them. Then I have one number representing each group. If I were to have two groups, I'm gonna have two numbers. At the end, I'm gonna have an average, or we call it mean score. Let's say, for sake of argument, this is 50, that is 40. Just made it up. We're gonna compare. This 50 represent all of these students. 50 is expected to be the best number to represent the whole group. Some will be less than it, some will be more than it. 50 is the perfect fit for our purposes. We will look at these numbers and we will run some statistics. By naked eye, I can see this number is higher than that. Maybe this happened by chance. Because even if you randomly pick 30 people and you divide them by 2 and you randomly give them and take their average, the mean averages will be different. Each sample will have a different score. So that difference of 10, whether it's good enough, it's because of this treatment or it's because of the error, random, will be determined by performing some statistics. Now, look at the design. When you have 2 groups, you have 2 numbers. You subtract them, you divide them by something, and you get some table, and you're done. But when you have 3, you compare group 1 with 2, 1 with 3, 2 with 3. There are 3 different comparisons. This is ANOVA. ANOVA is what you learned in statistics class last week. Your term project was on ANOVA. So comparison and finally control. While we are doing something in one group we don't do any. It is called the control group. So we see how much deviation, how much variance is happening from the control. 4 aspects of it. One important thing that I want to emphasize, I wish was added, randomization. Randomization and manipulation. These are 2 most important aspects of experimental design. So if you look at this from another view, first you create a pool of participants, people that you're gonna work with during your study. You randomly assign them to one of these 2 groups. One group treatment A and treatment B. One group treatment B's control group. And then once you do that, you calculate their mean score, and then you compare their mean scores. You perform some statistic tests, Z test or T test if there are 2, F test 3 or more. And then you check out the other variables. And then you try to control them. So talk a little more about these other variables in a minute. So independent variable is the variable that is calculated by the researcher by creating a set of treatment conditions. Now realize in correlational studies, independent variable, not smart to talk about independent variable. In correlational design, we don't manipulate any. Nevertheless, even in correlational design, sometimes whichever is more like fixed intelligence, we would like to think that as our independent variable. And the product of that variable, like achievement, which is, uh, intelligence comes, then the function of intelligence, people's performance can be measured. We may call that, but there is no point in correlation of this. So independent variable, treatment condition, a situation or environment, we call that level. And we have 2 levels, 3 levels, or more levels. Having number of levels, minimum 2, will tell you how complicated your study is. The dependent variable is variable that is observed or changes to assess the effects of manipulating. Now, one thing that I want to emphasize is right here, this independent variable. This is a categorical variable. It's a categorical variable. It's not a continuous variable. What's continuous? How would you put them in groups? If you'll have infinite number. If your independent variable is continuous, then your study is an advanced one. It requires certain courses at doctoral level. You have to be exposed to certain other design methods for you to perform. So for our purposes, for this course, every independent variable, we will consider it as categorical variable in true experimental design perspective. Dependent variable, on the other hand, is continuous. It's a number. Okay? It's a number. If it wasn't a number, if it was a category, then you wouldn't be able to perform usual tests. You would have to use chi-square. So for our purposes, for this course, every single time you see dependent variable in chapter 10, 11, and 13, it's going to be numerical value. If it was categorical value, now let's make up an example. Okay. Does ethnicity, let me simplify this, ethnicity and political affiliation. Can I tell you what party you are going to vote for based on your ethnicity? For that, there are two parties. Creating this table is, if you are able to create a table, then you are good to go. The rest will come easy. So I need basically something like this. Here I'm going to have ethnicity. Here I'm going to have Republican and Democrat. And for races, we have white Americans, Black Americans, Asian, and then Native Americans, and Hispanic, obviously. Okay. So, and I'm going to check how many, whatever study I have, how many white voted for Republican. I'm going to have numbers here. Instead of having a score for an individual, now I have a count. This is a count. Count. It's a frequency. Therefore, I cannot perform a z-test or t-test. It has to be chi-square, which is not the subject of any of these. But I want you to be aware of, at least when you read an article, it should help. So what we have is dependent variable is measured, independent variable is manipulated, and then there are extraneous variables. Any variable that is not independent variable or dependent variable is called extraneous variable. Some variable that has an impact on what it is that we are studying, DV, dependent variable, has an impact on it. Like in this study, playing a video game, violent video game, watching a violent video game versus aggressiveness. So participants' personality. Some people are calm, even if they play video game, violent video games. You will see very little change. Some people have a temper, their height, their weight, environmental variables, season, whether it's in summer or it's all of these are variables of interest. We want to think about it. We want to talk about it. Okay. If any of these variables has huge importance, then it becomes a problem. Then we have to talk about how we control for that. So the third variable problem is a study may establish that two variables are related, but it doesn't necessarily mean that there is a direct result. It could be a third variable that is responsible for this. But purpose of that slide is to warn you against making such mistake. Think about, here we're gonna gather kids age 6 through 12. These are our participants. We're gonna measure their weight or height, and then we're gonna measure their math performance. Okay. Do you think we will observe a correlation? Certainly. A 6-year-old is in first grade, 12-year-old is in middle school. So a 12-year-old, as age goes up, math competency will increase as well. But it doesn't mean weight is responsible for math competency. There is a third factor or other factors like intelligence, or in this case, certainly one factor, schooling. What-
Eşek mi? Bir sus.
All right. So in this case, schooling and biological maturation are related. So that discussion, and you can find more in the book, question of third variable, when you see two things being correlated, and something goes up, the other goes up. And the textbook goes into detail, and I think there is maybe there is another line. Here in this example, it's too easy. Sometimes it's not that easy. Right. So basic goal in demonstrating a cause-effect relationship is to demonstrate that cause happens first. This cause happens before the effects of effect occur. So the value of independent variable is followed by a change in the dependent value of dependent. And we also need to establish that one specific variable is responsible for change, not some other third. So to do that, we have to control third variable. If you believe, so the way to control it, we have different ways of doing that. You could make it a part of. Thought I had slides somewhere. If not, I will put it here. If you think that there is a variable other than dependent variable you're studying, like intelligence, yeah, I think it's in the next chapter. You think intelligence is a factor, then you can do a couple of things. Number one, you can make it a variable part of study. Measure their intelligence and check it as a covariable. Number two, keep it match. For each person whose IQ is 105, find a person IQ is 105 in the other group. Or make it a part of study, match or keep it fixed. How? Make sure every person in your study has similar IQ. Somebody's IQ is too high, eliminate. Somebody's IQ is too low, eliminate. Keep it fixed, constant. Keep it constant. And I will talk about these three in one of the slides. So just because weight is a problem, or aggressiveness, for example, it doesn't mean we have to worry about it. We should worry about if it systematically impacts our variables. If it doesn't systematically affect, it's not a problem. If it changes at random, no relation to the independent variable, it's not a threat. Why? Because the keyword is random. In statistics, random numbers are distributed normally The whole statistic is built on this random distribution. When random error is randomly distributed. So error is normally distributed. Because of that, it's gonna cancel each other. Right, so in chapter 7, we try to define the experimental design. In chapter 8, we're gonna tell you how one of the two ways you could have an experiment between subjects. So there are two. One of them is within chapter 9, and between this is chapter 8, what we're gonna learn. So within is one group of individuals is given a memory test using a list of one-syllable words, and the same set of individuals also tested doing so. In within, you have 30 people. Okay, you have 30 people, 30 students. First, you introduce treatment A. Treatment A. Then you introduce treatment B. What happened is you have 30 people. For each person, you get 2 numbers. That is within design. Meaning you have one group, your performance, your treatment is within one group. Has its own advantages and disadvantages. Talk about this in chapter 9. In chapter 8, between subject design is you have 2 treatments or more. Each group of participants is different. Meaning you have 60 students in total, 60 participants, 30 in each, and each person gets one value for DV. You measure it once for each. That is dependent between subjects. So, experimental research, wherein a researcher manipulates an independent variable, then measures dependent each participant. That is the definition of it. Then measures once the dependent variable for each. Our goal is to determine whether differences exist between 2 or more treatment conditions. It requires only one score. Separate groups of participants are used for each condition. It's simple as that. It's nothing complicated. In subject design, you have a set of participants. You assign them to one of these two. Within, you have one group of person. Each person in the study is subject to at least 2 treatments. So between design, visually speaking, you have them here. You randomly, that is the word, randomly assign them to levels. These are levels. In this case, there are 3. And then you introduce the treatment 1, treatment 2, and probably control. And then you get their average score. And you compare these average scores. If you have 2 scores, you have z-test or t-test, depending on the assumptions. If you have more than 2, you have ANOVA. If you understand this, congratulations. You can read more than half of medical studies conducted today in the United States. Each individual score is independent from all other scores. Advantage of between subject design. There is no contamination. Each person, you measure it only once. Therefore, there is no, experience. Like if you have same people and you introduce them to treatment A, then you wait and you give them treatment B. Imagine this is like, especially in education, these people will have experience. And there will be some carryover effect to that experience. And that's not something we want. It's contamination, error. So in between subject design, you don't have that because you have different individuals and you test them only once. Fatigue, when you introduce each person to tests, they get tired, especially if procedure is long. They get bored. When they get bored, it increases the environmental error. Measurement error goes up, and that contaminates your results. And a contrast effect that results from comparing one treatment with another. That is also a strength for between subject design. The disadvantage is you need more people because for each group you need a certain number. If you have n participants in each group, if you do within design, n people is enough. You do between subject design, depending on how many groups you have, you are going to have to multiply that by n. Very different, requires you 3 times. Each score is obtained from a unique individual who has personal characteristics. When you do within, one of the advantages of within, because you are measuring twice on the same individual. Same individual, you are eliminating any, any variable like individual's intelligence, gender, history, past performance. The same individual. Versus when you compare one individual score with another, each individual has different IQ scores. There are so many different. So the groups in a between subject experiment must be as similar as possible, except for IV. So our job is, there's a principle in experimental design. It's called max. Our job is to maximize systematic difference. If I have 3 groups, think about right here. I have 3 groups. In each group, I have 10 individuals. There are scores. Overall, there will be like a 40. Add them up. That's what research shows actually. 50, 40, and 10. That 50 average has, if we dissect that 50, that mean score consists of each individual's score. Each individual score has an impact from, because they are in teacher assigned goals, your score is going to be different. Impact of being assigned to this, that is the systematic difference. That is what we are trying to distinguish. There is also individual differences. This person is a high achieving person. His score is a little higher. That is not what we want. That is error. We want to maximize principle of maximization, maximize systematic variance. Variance is, this person's score is 55. Well, actually, we have an example here. Look at people in the control condition and people in treatment condition. If you look at them, these scores are closer to each other. That's what we want. They are close to each other within variance. Within variance, something you may remember from statistics, the denominator of your F is low. These people are similar to each other. That's what you want. And those people are similar to each other. That's what you want. Nevertheless, overall group difference, this group is low, this group is high. Why? Because it comes from the treatment. whatever treatment condition these people are taking increases whatever it is that we are measuring. That is systematic. We want to increase that. We want to minimize the differences between disciplines in each group. We want to minimize any extraneous error, any confounding error. We want to try to keep both group conditions the same. We want to set the AC temperature the same for both groups. We want to have teachers read the same instructions to both groups. We want to make sure it's the same time of the day. It's not when they're tired. Okay, and that will minimize these. And finally, constant. If something is affecting our independent variable of intelligence, we try to keep it controlled. Control anything that is not relevant to the extent possible. Then you have yourself an effective study. So, two major sources of confining designs. One comes from individual differences. Each person in each group, their age, their IQ, their height, if relevant, or socioeconomic status, or parental education level, whatever, or academic performance, that is source of error coming from individuals. And then there is environment. Like that the AC is not working, for example. One group is in one room and there is too much noise. Okay? One person, some people are hungry in one group. These are going to affect your study. They are environmental. Our job is to control these kind of differences. We want to have our groups equivalent. So make sure they are created equally, they are treated equally, same instructions are being read to them, and they're composed of equivalent. You don't want to have, like, in one group, you have older kids, and in another group, you have younger kids. Your textbook has an example. Maybe age is a factor. You don't want to. So, in order to limit those confounding errors, you can either randomly assign them, match them, or you can keep it constant. Randomization is the essential part of when you randomly assign people, you ensure that even though you have 30 kids, their IQ score will be different, but when you randomly assign them, they cancel each other out. Statistically speaking, you can mathematically prove that claim statistically. All right. So I explained this. What we want is in one group, want to have, these scores close to each other, and those overall group mean far from each other. Remember the definition of variance. Variance is, imagine, let's say for sake of argument, we have only 3 numbers, 6, 7, 8. Their average, this group average is going to be 7. And here we have 6, 10, and 14. 3 numbers. Their average is 7. That's what I mean. And the mean for this is 7. Variance, on the other hand, is how far scores are from each other. 6, 7, 8 are right next to each other. 11 apart from each other. If we want to quantify this, want to calculate that, let's put this here. What we do is we subtract 7 from 6. 6 minus 7. This is called deviation score. -1 is called deviation score. How far it is from the mean. And 7 minus 7 is 0. And 8 minus 7 is positive. And then we square these numbers. Remember from statistics. square them, and then we add them up, 2. And then we divide this number by sample size, which is 3. We take their average. So variance in this case is 0.67. Over here, it's going to be different. Average is 7. So 3 minus 7, -4. 7 minus 7 is 0. 11 minus, and then we square them, and then we add them up, and then we take their average. 16 variance versus less than 1. So this is variance. When you look at these numbers, the variance within these scores are not too far from each other. Those scores are not too far from each other. When you graph them, it becomes not very realistic. It's something that we would like to see. Versus your, people in your control group. This is their. You see, one of them is here, and the other is all over here. Within error, within variance is too. Get the variance score. These are too far from each other. So this study is problematic. You wouldn't know if the difference between the control and treatment is coming from your independent variable or is coming from nature of your people in your study. You don't want that. So let's go back to here. Look at the study. There are 36 graders, and then you see their IQ is being reported. That's what makes the study so good, so well organized. Their IQ is between 85 and 110. Their mathematics achievement score is a nationalized score. It gives us an idea. These are students with learning disability, so they're underachievers, obviously. And then how treatment conditions are designated. Self-set goals, that's your control group. No, I'm sorry, that's your group 1. These kids assign their own group, own goal. Basically, what it is, they say, I plan to study for this. I plan to finish 4 pages, 10 pages, and the number that they come up with, they decided on their own. Then we have another group, 9 goals. Here, the teacher tells them, I want you to have this goal, try to finish this. And finally, no goals, which is our control. Then for each group, there's a pre-test and post-test. Makes the study really, really good. We'll skip that for now. We'll just look at the difference between these two scores. 3 groups, ANOVA is needed. And because they are interested in covariance, they did this in COVA, which is a little more advanced in master's degree level. But it's not that complicated either. So that is the structure of a very good version. Now, I wanna again, my goal was to help you understand. You can read the textbook better. That was my whole goal. So if we go to this website, the government website, Department of Education, and I'm gonna type 2 words, effect. I'm gonna use this version, effect, and I'm gonna use education. Let's see what comes up. Now, right here, look at this title. Effects of, I have no idea what this study is about, but I'm gonna look at the title, and I'm gonna tell you effects of mediation learning interest in improving student learning. Now, this experimental design, it is to be improving effects. Now, if we go into it and see for ourselves what they did, how they assign people is their manipulation. 200 respondents, not. It's a correlational step. You see, I just did one sentence. It's enough. The samples are 200 respondents for study group. Respondents' characteristic data included gender, age, latest education, and years of service. Abuse. The usage of term effects. You can't conclude that. I randomly picked some. Effects of shadow education on high school students' creative thinking. Tool is not available, but I wouldn't be surprised if it's also not a true experimental design. Causal effects of education. You can't do that. This is impossible to do. Okay. For you to do that, effects of education or welfare participation in US, what the title says, we're going to have some students, some adults, because it's welfare or some kids, doesn't matter. And we're going to manipulate their educational level. We're going to say, hey, you'll be a college graduate. You can't do that. And then we'll see how many of them are Medicaid partners. How many of them take, help from the government for food or for health insurance. Abuse of the terminology. Most studies published, way more than half. So with this course, at least when you come across a study, at least if you can judge it, and then you decide whether you should believe it. At minimum, you should be capable of doing that. So conducting a true experimental design is not easy. And if you want to see two good examples, one of them is in the textbook, explained, referred from time to time, right here. And the other one is the one I posted. There are thousands of good experimental designs. These are just two examples. All right. I'm going to end the session. If you want, you can leave. If you have a question, I'm going to stay here until try to answer your questions. I'm going to wait here until you don't have any questions.
No question. Thank you, Professor.